Hey there. I want to just do a couple of short little videos here for you to explain some of the stuff you're seeing in this trig unit. So the first thing I want to talk to you about are trig functions. Basic trig that we're talking about here, this is an expansion of the trig functions and things that you learned in geometry. So in geometry, we learned about right triangles, and we learned that there are three parts to a right triangle. We have an opposite side. Notice that this is the side that is opposite the angle theta. It's across from it. Adjacent is the one that touches. And then the hypotenuse is the slant side or the longest side. It's always the side across from the right angle. And you have three trig functions. You have sine, which is the opposite side over the hypotenuse side. You have cosine, which is the adjacent over the hypotenuse. And you have tangent, which is opposite over adjacent. Now, in pre-calc, we talk about the other trig functions as well. Each trig function has its own inverse function. Sine is the inverse of cosecant. Notice they're flips of each other. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Cosine is the opposite of secant. Notice adjacent over hypotenuse becomes hypotenuse over adjacent. And then tangent and cotangent are inverses. We flip the opposite and the adjacent side. So for any angle, you can actually find 6 different trig ratios based on the sides of that right triangle. So looking at this triangle, theta is in this bottom corner here. We want to know what are the 6 trig ratios. So let's start with the first one, sine. Okay? Sine is opposite over hypotenuse. And I like to go through and label them all. So opposite is 2, hypotenuse is 5, square root of 5. Now, the one thing you have to remember is you cannot leave a radical in the denominator. We need to rationalize this, multiplying by square root of 5 over square root of 5, which gives us 2 square root of 5 over 5. That is the sine of theta. The cosine of theta, and I probably should be writing this correctly, is the adjacent side over the hypotenuse. So 1 over the square root of 5. Again, we have to rationalize. You absolutely cannot leave a radical in the denominator. That's not okay, okay? If you do that, they come and haul you off to math jail. Or you have to pay a math fine. I'm kidding, but you do need to rationalize, okay? Make sure that you are multiplying by that radical to get it out of the denominator. And here we end up with cosine is square root of 5 over 5. The last one to talk about is tangent of theta is opposite over adjacent. 2 over 1 is 2. Then we can go through and we can find the inverse of each one. So if we look for cosecant, instead of opposite over hypotenuse, we're going to do hypotenuse over opposite, square root of 5 over 2. Now, because the radical is in the numerator, I don't have to rationalize this. It's only when it's in the denominator. So this one is good. I can move on to secant, which is the opposite or the inverse of adjacent over hypotenuse, so hypotenuse over adjacent, square root of 5 over 1, which is just square root of 5. So again, we are using the 3 sides of our triangle to find the different trig functions. The last one is cotangent, which is adjacent over opposite, or 1 over 2, which is 1/2. Notice how each one is the inverse of the other. Cotangent is the inverse of tangent. Secant is the inverse of cosine, and cosecant is the inverse of sine. They're just flipped. Let's try one more. So this time we want to do the trig functions for the triangle, and let's choose angle A this time, okay? We'll make that our theta. Now, I'm missing something here. I'm missing a third side. So before I can start finding sine, cosine, tangent, etc., I need to find out how long is the hypotenuse. And I use Pythagorean theorem to do that. Remember, 6 squared plus 11 squared equals my hypotenuse squared. 6 squared is 36. 11 squared is 121. Add them together and I get 157. which does not have a nice integer square root, so I'm just going to leave this as a square root of 157. And I know that that's my hypotenuse. 11 is my opposite, and 6 is my adjacent. Because remember, my theta is angle A here, okay? Now I'm going to go through and I'm going to do my 6 trig ratios. I'm going to start with sine, which is opposite over hypotenuse. So 11 over the square root of 157. I need to rationalize that. So I'm going to multiply by the square root of 157 on both top and bottom, which gives me 11 square root of 157 all over 157. Now, sometimes it's nice to go through and do cosecant right away because it's just the inverse. It's the square root of 157, over 11. Done. Then I can move on to cosine, which is adjacent over hypotenuse. Again, I have to rationalize. And I get 6 square root of 157 over 157. Now the nice thing is I can come over here and I can do secant. And I'm just going to flip that and take square root of 157 over 6. Easy enough. The last one I want to find is tangent, which is opposite over adjacent. So 11 over 6. And cotangent would be the inverse of that, which is 6 over 11. So the 6 trig ratios are pretty easy to find, especially once you remember which ones go together. So sine and cosecant, cosine and secant, tangent and cotangent, and if you can label your sides of your triangle correctly. Remember that it's from the vantage point of the theta. So if you were standing here, which side would be opposite? 11. Which side would be next to you or adjacent? 6. And the hypotenuse is always the slanted side, if you will, the side that's opposite or does not touch the right angle. Okay. So there's your intro to the 6 trig ratios. I hope that that's helpful for you. If you still have more questions, let me know, but you can kind of see how these work.